Hello everyone, welcome to this session 4 on computer and communication network, and in today's session we are going to deal with network operating system and transmission media. So let me quickly take you through what we have done in our previous session. In our previous session we saw what a topology was, which was nothing but arrangement of computers in a certain fashion. And we saw the various kinds of topologies, like we saw bus topology, star topology, ring, mesh and tree topologies. And we also saw what are the advantages and disadvantages of these topologies. So in today's class we are going to talk about the two important elements of network. That is, one is called the network OS, also called as the network operating system, and the second one is called as the transmission media. Know that the network is incomplete without a network operating system and a transmission media. If a network has to make some sense, or if I want to say that if two or more computers has to be interconnected with each other in order to send and receive data or share data, then you must and should have a network operating system and a transmission media. So this is one of the most important aspects of network. So we shall see what a network operating system is and what is a transmission media in a network. Now before we understand what is a network operating system, which is also called as an NOS, remember NOS is an acronym for network operating system. First let us understand what an operating system is. So you all know what an operating system is. It is called as a system software which is required to run your computer. Suppose if you want to boot your computer, if you want to make your computer work, then you must and should have an operating system. So to be very techno specific, an operating system is a system software which interacts between the hardware and the user. It performs memory management, CPU management, it performs device management and so on. So let us not get too much into the operating system concepts here. We have a separate learning module exclusively for operating system. But right now understand that an operating system is a system software which is required to run your computer. Okay, now having said that, what is a network operating system? So a network operating system is a system software that controls the various devices on a computer network and how they communicate with each other. That means that if two or more systems are interconnected in a computer network, how these two or more devices will communicate with each other. Or if I have a printer connected to a network, and how do you ensure that the printer is shared among multiple computers? So those things are actually decided by your network operating system. So you can also see that it's an operating system that helps you to connect two or more systems on a computer network. So in the last class we saw various topologies, like you saw a bus topology, a star topology, a tree topology. Now topology was basically physical connection. Now we know that any system is incomplete. It should have both a hardware and a software component. The physical connections are all hardware components. You should have some software running inside that hardware to ensure that the computers are connected together and they create an justification for sharing and receiving data. So in that context we say that the network operating system is the system software which basically runs your network. Now there are different types of network operating system. Now I have given you one simple example of a network operating system which is a relatively a very simple network. Now what do you mean by a simple network? Here you have a building here. This building has basically got say 3 floors. You have a ground floor, first floor and a second floor. Now you have computers placed in all the 3 floors. So you see that your printer is placed in the ground floor and you have computers connected in all the 3 floors to the network. Now in such a case I can make this printer shareable. That means if anybody wants to take printout, they can give a print command and the printed document basically comes out in this printer. So in this case any of these workstations or a computer could have a network operating system. So in a relative simple network, one of the regular computers in the network can be used to run a network OS. That means this computer can be used to basically run a network operating system. So in more complicated networks, that is in particular those with large number of devices spread over different physical locations, then the network OS resides on a computer server. Now I'll just show you the picture of that. For example, look at this picture. Now I have a complicated network here where the computers are spread in multiple geographical locations. So in that case, you have a server here. This server would have a network operating system. So here we cannot have a simple computer to act as a server. You have a dedicated server here. This dedicated server will be connected to the multiple workstations or multiple clients over an network. So in either of the case, whether it is a simple network or a complicated network, simple network means basically where systems are connected in a limited geographical space, whereas in complicated network, what I mean basically here is the network where the computers are spread across in the different parts of the globe. In either of the case, you must and should have a network operating system. So some examples of network operating systems would be Windows Server 2016, Novel NetWare, Linux, Unix, etc. Of course, Novel NetWare is now becoming obsolete, whereas Windows and Linux are some solid examples of network operating system. Now that we have understood what a network operating system is, now we shall see the different types of network operating systems. Now there are two types of network operating systems, what we call them as peer-to-peer and client-server system. We shall see the difference between what is peer-to-peer and a client-server system. Now first we shall say what is a peer-to-peer system. Now we have a look at the arrangement of a computer here. So in this case I have four systems which are interconnected together in a particular fashion. Now I have told you that there are different names given to the systems when we connect them to a network. We can either call them as workstations, or we can call them as clients or nodes. Now one more name we can give them is called as a peer. Now who is a peer? A peer can either be a server or a client. That means he has a dual responsibility. Now it may sound little confusing here. Let me explain you with an example. Let us say that A wants to communicate with D. Now in this case D is requesting for a data from A. So D is sending a request message and A is giving a response message. That means A is sending the data to D and D is receiving data from A, which means that A becomes a server and D becomes a client. Similarly, there could be an instance where D is sending some data to A. In that case, D becomes a server and A becomes a client. So in the cases where both A and D are communicating with both request and response messages, now both can work as a server and a client. A server is a person who basically sends the data, and a receiver is one who basically receives data. So a peer is a system or a workstation which basically can send and receive data. So in that case, you need to have an operating system, and that kind of an operating system is called as peer-to-peer operating system. Now peer-to-peer network operating systems include legacy operating systems such as Apple Share, Windows 7 and Windows 8.1. Now these are some examples of peer-to-peer operating system. Now the second kind of operating system, network operating system, is called as an client-server network operating system. So in this case, you have a dedicated server, as you can see here, and this server will be connected to a number of clients, workstations. Now this server could be a file server, or it could be a web server, or it could be a database server, it could be a transaction server, it could be an email server. So all these are different types of servers. They're connected to the client. The client will place a request and the server will service the request. So you have a typical client-server architecture where the server's main responsibility is to serve the data and the client's responsibility is used to receive the data. Now this is an example of an client-server network. So operating system where Unix and Windows servers are examples of your client-server operating system. And if you want to give me the examples of client-server networks or client-server operating system, how it works, your email and internet are solid examples of client-server operating systems. Now Knowing this much, we need to now look into the transmission media. As I told you that the transmission media is also an important element of a computer network. Now, we know that a network is a combination of multiple computers which are actually connected together in order to transmit data. And in order to transmit data, you need signals, because signals are the representation of data. And if the signal has to pass from one system to another system, it needs to have a media. So they're all interconnected with each other. So now this media can be of two types. You have something called as a guided media, and you have something called as an unguided media. Now the key difference between guided and unguided media is that the guided media uses a physical path or a conductor to transmit the signals, whereas your unguided media broadcast the signals through air. So that is the basic difference between guided and unguided media. So there are some examples of guided media, like you have a twisted pair cable, you have a coaxial cable, you have an optical fiber cable, whereas in unguided media you have a radio wave, a microwave, a infrared transmission, and a satellite wave transmission. So these are some of the examples of guided media and unguided media. Now we shall see the different guided media. The first cable we are going to look into is called as a twisted pair cable. Now you can see the picture here of a twisted pair cable. Now the twisted pair cable is made up of two plastic insulated copper wires twisted together to form a single media. Now you can see that the insulated copper wires are actually twisted. Now actually there are two wires which are here which are actually twisted, and the intention of this is one of the wires will actually carry the signal, and the other is used for ground reference. So the signal is not carried in both the wires, only one wire is carrying the signal, and the other is actually used for ground reference. Now why do you need to twist? Now there is a important phenomena here. What is the use of twisting this? You basically twist the wires because it helps in reducing the noise and crosstalk, because crosstalk or noise is one of the common phenomena which is exhibited in any signal transmission. So to order to avoid that, you basically twist the cable. So this is how your twisted cable look like. We also call it as a twisted pair cable. That is the correct name for it. Then the second type of cable is called as an coaxial cable. You can see the bisection of a coaxial cable. You have a copper wire in the center, that's a solid copper cable. On the copper cable you have the insulation, and that insulation is covered by a copper mesh, and that copper mesh is again having an outside insulation. So this outside insulation will protect the entire cable from weather conditions, and the actual data is carried in this copper wire. So you can see this coaxial cable implementations in your cable televisions, and also small local area networks where they are connected using a BNC connectors. So coaxial cable is a relatively simple cabling technique. Now the third one is called as an fiber optic cable. Now this is very important. Now as the name itself indicates, fiber optics deals with light technology in order to transfer the data. So they make use of light transmissions instead of electronic pulses, unlike your twisted pair cable and a coaxial cable. Now where do we use this fiber optic cable? We use it for transfer of data, video and voice transmissions, and it is the most secure way of transmitting the data, because you cannot simply tap into the data of an fiber optic cable. Now this is basically consists of multiple parts. You have a core, on that you have a cladding, then you have a coating, then you have strengthening fibers, and you have a cable jacket. Now core is made up of either plastic or glass. This is where the actual light is transmitted. On that you have a cladding. Now cladding basically covers the core. This is because when light is being transmitted, the light should not seep out. If the light seeps out, then the information is lost. Therefore the cladding ensures that the light is remaining within the core. On the cladding you have a coating. Now that coating is an buffer layer which is basically helping you to ensure that the cladding and core is supported. And above that you have another strengthening fibers type of a thing. Now the strengthening fibers will ensure that all these three layers, that is coating, cladding and core, they are all well protected, because when you are installing fiber optic cable, you are ensuring that the cables are bent, they are straightened, they are basically mishandled sometimes. So in order to keep the core, cladding and coating intact, you have a strengthening fiber, so that it will protect the core against excessive tension during installation and other crushing forces. So above that you have a cable jacket, which basically helps you to protect the entire cable from weather conditions, extreme weather conditions, to be in very precise. So these are some of the cabling techniques what we use in guided media, that is your twisted pair cable, coaxial cable and fiber optic cables. Now coming to unguided transmission media, we have radio waves, we have microwaves, we have infrared transmission, and we have satellite transmissions. Now where do we use radio waves? The radio waves are used in the frequency range of 3 kilohertz to 1 gigahertz. Know that in an unguided transmission media, you don't have any physical media. The entire data is transmitted through air, that is signals are transmitted through air. So these radio waves are basically used for multicast communications like FM radio. So most of you must be using FM radio. So in that case, we make use of radio waves. Now anything more than 1 gigahertz frequency, we make use of microwaves. It is also called as the line of sight transmission, which means that signals travels in a straight line. So whenever you want the signals to be transmitted in a straight line, the point to point contact, then we have to make use of microwaves. So your communication devices like cell phones, satellite networks and wireless LANs, they all work on microwaves. Then coming to the third transmission media of an unguided type, we have an infrared transmission. So infrared transmission makes use of infrared light to send information, and they are basically used for short range transmission. For example, transmission within a room. Now one common example what we can think of is a TV remote. So your TV remote, which is used to control the various channels on your TV and also control the various controls on your TV, is basically an infrared transmission. And your car remote, some wireless speakers what we use at home, they all make use of infrared transmission. Now the last one would be a satellite transmission. This has got two things which you need to understand. One is called as an uplink signal and a downlink signal. The uplink signal is the signal which is basically sent from the relay station to the satellite, and that frequency is around 6 gigahertz. And signal from satellite to the earth is called as a downlink signal, and that frequency is around 4 gigahertz. So all your various cricket telecast what you see, are weather forecasting what you see, and other things which are important, some live telecast which is happening in different part of the earth, which you can see on your television, they all happen through satellite communication. So this is what I had to tell you in today's class, where you learnt about what is a network operating system, and you learnt about the different transmission media. You learnt about both the guided media and unguided media, and we saw the various cables what we use in the guided media, and we also saw the different types of unguided transmission media. So thank you for being with me in this session. I'll see you in the next session with more details on computer and communication network. Till then, take care. Bye bye.